Hey guys, just wanted to show my cell conditioning. You can see it's producing hydrogen, and this is in a cooler, and all I did was fill the cooler with tap water from the sink over there, but there's no electrolyte other than what comes in, heavy water here in Montara. I'm sure there's a lot of iron in the pipes and stuff like that, so I have to account for that. But I didn't add any additional electrolyte. And this is just conditioning, so I have it running on a battery charger, and if you can see, it's set for 12 volts right there, and it's set on the 2 amp trickle charge, but the cell is pulling, I don't know if you can see that, just over 4 amps. So at 4 amps, 12 volts, brand new cell with no conditioning, and this is the output I'm getting so far. So I think I'm doing pretty good. This wire is obviously temporary. This speaker wire I had left over. But, once the cell conditions, I'm going to run it like this for about 30 minutes, stop, and then tomorrow I'll do it again, 30 minutes, stop. 30-minute chunks, and start building up the amperage. I should get a nice white coating on the inside, the negative anode, and it should start, the bubbles of hydrogen should actually start to get bigger. At that point I can take it out of the cooler and put it in the case that it's going to go in soon. Okay, that's the progress I've made so far. No electronics yet. Just a battery charger. The electronics that I'm working on, I'll be able to plug it into the wall. It'll come out of the wall, get stepped down to 12 volts, maybe. This is 2 different circuits I'm working on, so 12 volts. And then it'll go from 12 volts into my pulse width modulator that's gated and a pulse frequency, so I can set the frequency and the gate of that frequency to get the rest of the circuit to actually ring. So it'll come out of that and into a high voltage step-up transformer, then out of that into a buck converter. And the buck converter will turn the very high voltage into very high current, and lower the voltage, which is what the cell needs to actually run. And the beauty of that is there's back EMF on a buck converter, and my goal is to capture that back EMF to charge a bank of capacitors to go back into the circuit when the cell requires it. It should aid in efficiency and make the whole thing run, significantly better. The whole thing is how much power does it use out of the wall, and it's not how much it goes to the cell. I don't believe that's where we really need to focus. I think out of the wall is perceived power consumption. So if we can make that as little as possible, then it really doesn't matter what goes into the cell as long as we're producing something that's usable. Okay, that's where I'm at. Talk to y'all later.